Welcome to my video on multiplying rational expressions, part 1. When multiplying fractions, cancel first, then simplify. And I'll do that by working out some of these. Simplify each. So what we're going to do is cancel. Now I could, if you think about it, multiply and get 4 sevens are 28. And 21 times 2 is 42. And then I can reduce 2 into 28 goes 14. 2 into 42 goes 21. And 7 into 14 goes 2. 7 into 21 goes 3. But what you're doing when you multiply these, you're making it larger, and then you got to reduce it down. It's better when you're multiplying fractions to cancel from top to bottom anywhere. Because you're multiplying, you can cancel anywhere from numerator to denominator. 2 goes into 2 once, 2 goes into 4 2, 7 goes into 7 once, 7 goes into 21 3. So 1 times 2 is 2, 3 times 1 is 3. Much quicker to cancel when you're multiplying. Remember, you can only cancel when you're multiplying, not adding, subtracting, or dividing. And again, we're multiplying. Can we cancel? Notice that you can cancel anywhere. You can cancel the 3 into both of these, or you can cancel the 5 first. So 5 into 15 goes 3, 5 into 20 goes 4, 3 into 3 goes once, 3 into 9 goes 3. So I have 3 times 4 is 12 over 11. Leave it as a fraction. And because we're multiplying again, I'm going to cancel. So I see a 15 and a 30. 15 goes into 15 once, 15 goes into 30 twice. 2 goes into 2 each, 1 each. And we have a 1 here, a 1, so we have a 3, and 7 and 8 don't have a common factor, so 1 times 3 is 3. 7 eighths are 56, totally simplified. Practice means pause your video and work each uses out and press play when you get it done. We're multiplying so we can cancel anywhere from top to bottom. So 6 into 6 goes once, 6 into 12 goes 2, 2 into 2 goes once, 2 into 14 goes 7, 7 into 7 goes once, 7 into 14 goes 2, so 1 times 1 is 1, 2 times 1 is 2. Number 2, we're multiplying so we can cancel anywhere from top to bottom. 5 into 5 goes once, 5 into 10 goes 2. 9 into 9 goes once, 9 into 18 goes 2. 2 over 2 cancels 1 over 1, so we get 1 on the top, 1 on the bottom, and that's just the same as having 1. Number 3, cancel anywhere from top to bottom, provided you're multiplying. So I can see 5 into 25 goes 5, 5 into 30 goes 6, and I can see 5 into 5 goes once, 5 into 5 goes once, 2 into 2 goes once, 2 into 6 goes 3, 13 into 13 goes once, 13 into 26 goes 2, 1 times 1 times 1 is 1, 2 times 3 times 1 is 6, fully simplified. Cancel only when you're multiplying. The multiplication of rational expressions is the same as the multiplication of fractions. Cancel first and then simplify. So we're multiplying fractions, so let's cancel. 5x divides into 5x once. 9's cancel. Let's see, 4 into 4 goes once, 4 into 12 goes 3. And I got a y squared divided by y, so the y's cancel. And I get a y on the top. Y divides into y squared y, or 2, subtract 1 is 1 extra on the top. So I have 1, x, y, so I got x times y. And I got 1, 1, and a 3. So x, y over 3. B, cancel. You're multiplying, cancel anywhere from top to bottom. So what I do is I start with x plus 4, and then I say, is it down the bottom? Yes. So I cancel once and once. Is the 3 cancel? No. X minus 2 is here, and here cancel. So I get 1 times 3 times 1 is 3. 1 times 5 times 1 is 5. C, you're multiplying, so you cancel anywhere from top to bottom. So will 4 cancel? No. X minus 1 cancels once. X minus 1 cancels. 21 can cancel. 7 into 7 goes once. 7 into 21 goes 3. X plus 3, top and bottom, they cancel. So I get negative 4 times 3 is negative 12. And 1 times x times 1 times 1 is x. Fully simplified. D, we're multiplying, so we cancel. And I see an x plus 4 top and bottom, cancels. I see a 2 into 2 goes once, 2 into 6 goes 3. 3 into 3 goes once, 3 into 15 goes 5. So x times 1 is x. And 5 times 1 is 5. E, we're multiplying, cancel anywhere from top to bottoms. So I got a 6. Is there a factor of 6 down below, or 6 into 6 goes once, 6 into 12 goes 2. X minus 1 is not down the bottom, so we can't cancel. X plus 2 is here and here, so we cancel 1, 1. X minus 3, 1, 1. And that gives me 1 times x minus 1 times 1 times 1 is x minus 1. And x times 1 times 2 times 1 is 2x. And F, we're multiplying again, so we cancel anywhere from top to bottom. Now what I normally do, I start here and I go across. As I go across, I look for the first one. I say, is that down below? Yes, so we cancel it out. X plus 2, is it down below? Yes, cancel it out. And the x squared, x cancels into x squared x, and the x cancels into x once. So the top is 1, the bottom is 1, so that becomes just 1. And notice when you're multiplying fractions, you cancel anywhere from top to bottom, provided you're multiplying. And practice means pause the video and work each of these out one at a time to see if you're right. Simplify each. So we're multiplying, so we cancel anywhere from top to bottom. So I see a 2a once, 2a as a 3. I could have canceled the a's, and then 2 into 6 goes 3. X cancels into x once, and I see a 3 once, and 3 into 9 is 3. 1 times 3 is 3. 1 times 5 is 5. Number 2, we're multiplying, cancel anywhere. Can 3 cancel into 5 and 4? No. X plus 7 is on top and bottom, cancel it out. 4 into 4 goes once, 4 into 40 goes 10. 5 into 5 goes once, 5 into 10 goes 2. And I have an x on the top and an x squared on the bottom, so the x cancels once, and the x cancels here to give me x, because x divides into x squared x. 3 times 1 times 2 is 6, and I got a 1 times x times 1 times 1 is x. And if you do not cancel fully, when you get to this step here, you got to check to make sure, see if you can cancel here. That's possible, because sometimes you make a mistake and don't cancel it at all. Up here, you might have to cancel it down here again. Number 3, is there, you got an x, is there an x on the bottom right here? Yes, cancels. Is there an x minus 1, top and bottom? Yes, right here. 3 and 6, 3 goes into 3 once, 3 into 6 goes 2. X plus 2 is on the top and bottom, cancels. 1 times 1 times 2 times 1. 1 times 1 times 1 is 1. So 2 over 1 becomes just 2. Number 4. I have an x as a factor. Do I have an x down the bottom as a monomial? No. Do I have an x plus 6? Yes. Cancel. Top and bottom. Do I have an x plus 1? No. Do I have an x minus 2, top and bottom? Yes. Cancels. So I have an x times x plus 1. And I have a 2 times x plus 7. So notice x can't cancel with the 2, x plus 1 can't cancel with x plus 7. And remember, you can only cancel x plus 7 if it's on the top right here as a factor. Number 5, I have a minus 2 and I got a minus 10. So negative 2 divided by negative 2 is 1. Negative 2 into negative 10 is 5. X minus 3 is here and it's right here. Cancel ones. 15 and 5. 5 into 5 goes once. 5 into 15 goes 3. Do I have an x plus 2 on the top? Do I have it on the bottom? Yes. Cancels. And so we have 1 times 3 times 1 is 3. And I have a 1 times 1 times 1 times x minus 3. Notice I had 2x minus 3's on the bottom. So I could have canceled that one into that one and left this one alone. But because they're over each other, I cancel these first. Number 6, 8 is monomial in 6. So 2 and 8 goes 4, 2 and 6 goes 3. And notice 3 into 3 goes once, 3 into 3 goes once. And I have an x minus 1 on top and bottom, so they cancel out. I have an x on the top that cancels with this, make an x, because x divides into x squared x. X plus 1 is on top and bottom, they cancel. So I got 4 times 1 is 4, and I got a 1 with an x. Perfect. Now we have 3 multiplications. Notice we can only cancel when we're multiplying. You hear me say that over and over. So you start. I start right here, and I move. Do I have an x on the top? No x on the bottom, so we can't cancel. Do I have an x plus 10 on the bottom? Yes, they cancel. Do I have an x minus 1 on the bottom? Yes, so they cancel. As long as you cancel from top to bottom, numerator to denominator. But you have to be multiplying. There's multiplications here, so we're okay. Do I have an x minus 2 on the bottom? Yes. So note I'm working going right. Do I have a 9x? I have a 9. So 9 goes into 9 once, 9 goes into 9 once. And do I have an x plus 3? Yes. So notice I started here and went looking down. And I got an x times 1 times 1 times 1, that's an x. And I got, everything is canceled, they're all ones, except x plus 1. X over x plus 1. You cannot cancel these x's. You can only cancel if the bottom has an x as a factor by itself, or if x plus 1 is on the top as a factor. But you cannot cancel these two x's. You cannot cancel into an addition. Number 8, 7. Do we have a 7 down below as a monomial? Yes, once. Do I have an x plus 4? Yes, top and bottom. Do I have an x minus 6? No. Do I have an x plus 9? Yes, top and bottom. And so 1 times x minus 6. X times 1 times 1 times 1 is x. And again, you can't cancel these because that's a subtraction. Cannot cancel. Number 9, we have a 12. 3 goes into 3 once. 3 into 12 goes 4. 4 into 4 goes once. 4 into 40 goes 10. 5 into 5 goes once. 5 into 10 goes 2. See, canceling when you're multiplying, if you didn't, you would have got a 60 over 120. You would have to break that down, so it's better to cancel and then multiply. I have an x squared and an x cubed. So x squared is once, and that's an x. X squared divides into x cubed, x is on the bottom. I have a y to the 6 and a y. Y cancels into y once. Y cancels into y 6 5 times. Remember, when you're dividing 6, that's 1. 6 subtract 1 is 5, so there's 5 on the top. There's 3 x's on the bottom, x cubed, is 2 on the top. 3 take away 2 is 1, but there's 1 on the bottom. And we have 1, 1, 1, y5, so it's y to the 5th power, all over 1 times 2 times x. And number 10, we're multiplying, so we're going to cancel. And we start right here on the left and move like as if we're writing. So do I see a 7 down below? Yes, 7 and the 7 goes once, 7 and the 42 goes 6. Do I see an x minus 3 on the bottom? Yes, cancel. Do I see an x minus 2 right here? They cancel. Do I see a 3? 3 goes into 6. 3 and 6 goes 2. Do I see an x plus 8? Yes, they cancel. Do I see a 2? Yes, 2 and the 2 goes once. 2 and the 2 goes once. Do I see an x minus 6? Yes, cancel. Is there, I have all these gone. They're all ones. That's an x. They're gone. 1, 1, 1, 1, 1, 1, 1, 1. So it's an x minus 1. And I got 1, 1, x. So it all cancels out. They give you x minus 1 over x. And you cannot cancel that x into that x because this is subtraction. You could, if you wanted to, go like this, divide x into each of them, and that will give you 1 minus 1 over x. That would be another name for it, but this is as a single fraction. Now we have two fractions because 1 is 1 over 1. So this is okay. And so that's multiplying. Notice everything was factored. Everything that I showed you there was factored. And why did I do that? Because I just want you to concentrate on the canceling. So if you like my video, click the like button, the subscribe button, the notification bell, because there's more videos coming your way. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. The content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.